Good morning, students. Yesterday we have discussed some formula related to our NCR topic, which we have to learn in our chapter number 7. Now we are going to discuss some more questions or some more relations of NCR here. The second one, last one important relation is NCR plus NCR plus 1. This is most important relation or formula. NCR plus 1, which gives N plus 1 CR plus 1. Okay, NCR plus 1, which is equals to N plus 1 CR plus 1. Okay, in this formula we have to remember this thing. N will be same, addition symbol is there, N will be same, and difference between these two R is 1. Difference between these two terms is always 1. So see here R is there, here R plus 1 is there, therefore difference between these two terms equals to 1 here. Then we can write the answer N increase by 1, and greater R, So R and R plus 1. Which one is the greater R? R plus 1 is our greater term. Therefore, we have to write the greater term here. N increase by 1 and greater R. That means N plus 1 C. R plus 1 is your answer. Any applications here? 11C5 plus 11C6, then we can write, so N is same, addition is there, difference between these two R is 1, therefore we can write N increase by 1 and greater R, that means 6 is your answer. This is the application. Now if 10C5 plus 10C4 is there. See here, 10 same terms are there, and R difference between these two is 1. Therefore, we can write N increase by 1. Here addition symbol is there. It increased by 1. That means 10 plus 1, 11, and greater R means 5. Okay. So this is the application of NCR plus 1, which is equals to N plus 1 CR plus 1. How to remember? અને કઈ કઈ યાદ રાખશો? તો NCR એટલે ઉપર N same, નીચે R માં એકનો difference, then the addition will be equals to N increased by 1 and greater R. N increased by 1 and greater R. આ રીતે યાદ રાખજો, બહુ easily યાદ થઈ જશે. Now we are going to discuss the relations of coefficients and index. આપણે એ રિલેશન ડિફાઇન કરવા જવાનું છે, એ રિલેશન નું ડિસ્કસ કરવા જવાનું છે. તો we know that there are index, suppose this is the index and these are the coefficients. We know that the coefficients of terms A and B. Okay, the index, suppose one index is there, then we know that the coefficients are 1 and 1 here. Okay, if index is 2, then the coefficients are 1, 1 plus 1. Triangle થી તમને મળશે, but this triangle is known as Pascal's triangle. 1, 2, 1. If the index is 3, then we will get 1, 1 plus 2, 3, 2 plus 1, 3, and last one, 1. If the index is 4, then we will get the coefficients 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and last one, 1. Okay? If the index is 5, then we will get the coefficients 1, 1 plus 4, 5, 6, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and last one, 1. Okay? So these are the index and coefficients. How can we obtain these coefficients? We know that this is the triangle. We have to add these two terms, then we can obtain the coefficients. See here, same as 1 plus 2 3, 2 plus 1 also 3, 1 plus 3 also 4, 3 plus 3 6, 3 plus 1 4, 1 plus 4 5, 4 plus 6 10, 6 plus 4 10, same as 4 plus 1 5. So આ રીતે તમે continuously by use of Pascal's triangle we can obtain the coefficients of any term, the coefficient of any index. કોઈ બી a plus b ની index ના coefficients obtain કરીશું. આ coefficients obtain કરવાનો આપણને આ લોજિક તો ખબર જ છે, બટ હવે જે ડિસ્કસ કરવા જઈ રહ્યા છે એ બહુ ઇમ્પોર્ટન્ટ લોજિક છે, તો એની ઉપર ખાસ ફોકસિંગ રાખીએ અને આ લોજિક્સ થી જ આપણે કેલ્ક્યુલેશન્સ કરતા શીખીએ. તો ધ્યાન રાખજો. હવે આગળ જઈએ છીએ. Now we are going to discuss this relation NCR in form of NCR. Now see here, if the index is 1, if the index is 1, then coefficients can be written as 1. 1 can be written as 1C0. 1 can be written as 1C0. We know that NC0 equals to 1. Therefore 1C0 is always 1. And second one will be written as NCN. That means 1C1, which is also equals to 1. So we can represent the index and coefficients. Index 1 is that, then coefficients are 1C0 and 1C1. See here, 1 are the coefficients here. Now, if the index is 2, then we have to start with 2. 2C0, 2C0, 2C1 and 2C2. See here, last two things are 1 1, therefore we can write NC0 and NCN. Here n is 2, index is 2, therefore we have to write down 2C0 and 2C2, and this term will be obtained by addition of these two terms. Therefore we are getting this term by addition of these two. See here, 1C0 and 1C1, addition of the two terms 1C0 and 1C1, which is equals to, see here, n is same and difference between r is 1 here. Therefore we can write n increased by 1, 1 plus 1 2, and greater r means 1 here. 0 and 1, answer is 1, greater r is 1 here. Therefore 2C1 is there. If the index is 3, then we have to start with 3C0. Next, addition of these two, last term is also that 3C3. आगे तो fix है 1 1, NC0 and NCN, that means 3C0 and 3C3, and the middle terms can be calculated by use of addition of triangles. We are getting 2C0 plus 2C1, 2C0 plus 2C1, which will equals to 2 plus 1 3, and greater r means 3C1 here. Greater r, that means 3C1 here. Same way we can also calculate the next coefficient by adding these two, 2C1 plus 2C2. What will be the answer? Here n is same and difference between r is 1. Therefore we can add them and the answer will be 2 plus 1 3. Whatever, n increased by 1, that means 2 is increased by 1 3, and greater r, that means 3C2 here. Therefore we can write for index 3, coefficients are 3C0, 3C1, 3C2, 3C3. If you want to calculate this 3C2, then calculate 3C2. The answer will be 3C2 is always 3. 3C1, answer is always 3. આ તમે કેલ્ક્યુલેટ કરશો by use of formula NCR which is equals to n factorial divided by n minus r factorial into r factorial. Then we will get this one is 3 or this one is also 3 here. If the index is 4, then we will get 4C0. First one and last one is also 1. That means NCN 4C4. Now we will get the remaining coefficients by adding the coefficients 3C0 and 3C1. The answer of this 3C0 plus 3C1. Here n is 3 and difference between r is 1 here. Therefore we can calculate it directly. N increased by 1 means 3 plus 1 4 and greater r 4C1 here. If we want to add these two, then we will get 3C1 plus 3C2 which will be equals to 4C2. How it is possible? Because n increased by 1 and greater r. Okay, same logic is here. 3C2 plus 3C3 will be equals to 4C3. Therefore we can write the coefficients of index 4 of a plus b. We can write directly 4C0, 4C1, 4C2, 4C3 and 4C4 here. Clear? Next, if the index is 5, then we can write the coefficients directly 5C0, 5C1, next sequence 5C2, 5C3, next one 5C4 and last one 5C5. We have to start from 0 to 5 and we can also calculate by use of addition of these two. Okay, this triangle is known as Pascal's triangle. This triangle is known as Pascal's triangle. Clear? So by use of Pascal's triangle we can calculate the coefficient of any term, okay, any power of a plus b raised to n. If the power is n, then we can write down the coefficients like this. Power n is there, so power 5 is there, then we can write 5C0, 5C1, 5C2, 5C3, 5C4 up to 5C5. If the power is n, then we can write NC0, next NC1 coefficient, next coefficient NC2, next coefficient NC3 up to last NC n minus 1 and the last one is NCn. These are the coefficients of power n or index n of a plus b raised to n. Okay, we have to write down the formula for the a plus b raised to n. Later on we will see it. So write down up to this and logics થી તમે કોઈ બી coefficients obtain કરી શકો. હવે તમારે યાદ રાખવાની જરૂર નથી. હવે directly if I am asking for the coefficients of a plus b raised to 8, if I am asking for the coefficients of expansion of a plus b raised to 8, then we can directly write down by use of 8C0 first coefficient, second 8C1, third 8C2, fourth 8C3, 8C4, 8C5, 8C6, 8C7 and 8C8. Total 9 terms are there and 9 coefficients are ready here. Okay, if we want the coefficients of a plus b raised to 11, if we want the coefficient of a plus b raised to 11 by use of this logic, then it is very tedious, because we know that if we want the coefficient of a plus b raised to 11, then we want the coefficients of, we have to obtain the coefficient of a plus b raised to 10. For obtaining the a plus coefficients of a plus b raised to 10, we have to obtain the coefficients of a plus b raised to 9, same as a plus b raised to 8, a plus b raised to 7 up to, એટલે first થી સ્ટાર્ટ કરીને તમારે જવું પડે there is no direct logic here. But if by use of this, we can directly write down the coefficient of any power, any index of a plus b. Okay, for a plus b raised to 11, we can write directly 11c0, 11c1, 11c2, 11c3, 11c4, 11c5, 11c6, 11c7, 11c8, 11c9, 11c10, and last one 11c11. Okay, total 12 coefficients are ready here. By use of this logic, we don't have to derive the upper coefficients. ઉપરના coefficient derive કરવાની જરૂર નથી. ડાયરેક્ટલી તમારે જે ટર્મ્સ જે ઇન્ડેક્સના coefficient જોઈએ એ NCR ના ફોર્મમાં તમને obtain થઈ જશે. ઓકે, ક્લિયર? Now we are going to discuss what is the binomial theorem for a plus b raised to n. Binomial theorem for a plus b raised to n is given as a plus b raised to n is given as, which is equals to the coefficient, first coefficient, write down the coefficient nc0, then second coefficient nc1, the third coefficient plus nc2, the fourth coefficient nc3 plus nc4 plus nc5 plus up to second last coefficient nCn minus 1 plus last coefficient nCn. My first coefficient is write down first. Now we know the logic of power. Power of a will going to be decreasing from n to 0. A raised to 1, a raised to n minus 1, successive terms of power decrease by 1. Therefore, we are getting a raised to n, a raised to n minus 1, power a raised to n minus 2, a raised to n minus 3, next power a raised to n minus 4, next power a raised to n minus 5, up to last power a raised to 0, and the second last power is a raised to 1. The power of a is going to be decreasing from n to 0. Power of a is going to be decreasing from a raised to n to a raised to 0. A raised to n, a raised to n minus 1, a raised to n minus 2, a raised to n minus 3, up to a raised to 2, a raised to 1, a raised to 0 here. Okay? Next, we also know the power of b will going to be increasing from 0 to n. We know that from 0 to n, power of b will be increasing. B raised to 0, b raised to 1, b raised to 2, b raised to 3, next one b raised to 4, b raised to 5, b raised to 6, b raised to 7, up to b raised to n minus 1 and b raised to n. The last power of b is b raised to n. This is your binomial theorem for two terms a and b raised to index n or power n. So we can expand a plus b whole raised to n by use of this formula. This is the formula for calculating a plus b raised to any index. If a plus b raised to 5 is there, then we can calculate it 5c0. Put n is equals to 5 only. A plus b raised to 5. Therefore, we have to put n is equals to 5 here. We are getting 5c0, a raised to 5, b raised to 0 plus 5c1, a raised to 5 minus 1 means 4, b raised to 1. જો હું લખીને સમજાવું છું. See here, if we want a plus b raised to 5, then it is equals to, put n is equals to 5 in this binomial theorem. We are getting 5c0 a raised to 5 b raised to 0 plus 5c1 a raised to 5 minus 1 means 4. डायरेक्टली पावर डिक्रीज કરીને લોજિક સમજો તો બી ઠીક છે અને અહીંયાથી લખશો તો બી ચાલશે. And power of b will increasing for 0 to 1. Okay, plus 5c2 a raised to 3 b raised to 2 plus 5c3 a raised to 2 b raised to 3 plus 5c4 a raised to 1 b raised to 4, and last one 5c5 a raised to 0 b raised to 5 here. Okay, some observations given in your textbook. ये ऑब्जर्वेशंस હોય બોર્ડ પર લખવામાં ટાઈમ નથી યુઝ કરતો, તમે જાતે ટેક્સ્ટ બુક્સ માંથી લખી શકશો અને અન્ડરસ્ટેન્ડેબલ છે, તમને આવડી જાય એવા છે. જે કામનું છે એ લોજિક હું સમજાવું છું, ધ્યાન રાખજો. તો કામના લોજિક છે એ તમને મળી જશે, ખાલી ઓબ્ઝર્વેશન્સ તમારે ટેક્સ્ટ બુક માંથી લખી દેવાના છે, બરાબર? ચલો સી હિયર a + b raised to 5 તમને આ રીતે કેલ્ક્યુલેટ કરવા મળી જશે, બહુ ઈઝી છે. નાઉ the important logic, suppose we can write the expansion of, this is the expansion of a plus b raised to n. The expansion of a plus b raised to n can be also written as sigma r equals to 0 to n. Sigma r is equals to 0 to n NCR, sigma r equals to 0 to n NCR a raised to n b raised to n minus r. This is the also representation of this binomial theorem. This is the representation of binomial theorem also. How can be possible? The a plus b raised to n, which is equals to sigma r equals to 0 to n NCR a raised to n b raised to n minus r. We know that what do you mean by sigma? The sigma represents summation. Sigma means summation. Summation of these terms from r equals to 0 to r is equals to n. By putting r equals to 0 to consecutively r equals to 1, r equals to 2, r equals to 3 up to r is equals to n, we are getting this result here. How can it possible? See here, I am getting this result here, which is equals to sigma, that means summation from r is equals to 0 to n, that means we have to put the value of r equals to 0, r is equals to 1, r is equals to 2, r is equals to 3 up to r is equals to n. Therefore I am getting result. Put first r is equals to 0, r is equals to 0 in this step here. પહેલા તમે r is equals to 0 પુટ કરવાની ટ્રાય કરો. અહીંયા r is equals to 0 થી તમને ઓબ્ટેન કરશે. થોડું રિઝલ્ટમાં ચેન્જીસ આવો છે કે a ની પાવર n minus r છે અને b ની પાવર r છે. Okay, NCR a raised to n minus r b raised to r is your result. Now put r is equals to 0 here. We are getting NCR equals to 0. That means NC0 a raised to n minus 0. That means a raised to n minus 0, a raised to n and b raised to 0. Okay. Now, what do you mean by sigma? Sigma means addition, summation or plus. R is equals to 1. Now put R is equals to 1. હવે શું પુટ કરવાનું? R is equals to 1. So R equals to 0 માટેનું result plus R is equals to 1. So when we are putting R equals to 1, we are getting NC1 a raised to n minus R is equals to 1 b raised to 1. Now sigma means summation plus now put r is equals to 2, we are getting nc2 a raised to n minus 2 b raised to 2. Now we are putting r equals to 2, r equals to 2, then we will get nc2 plus into a raised to n minus 2 into b raised to 2 here. Next plus summation means plus, sigma means plus nc3 a raised to n minus 3 b raised to 3. Okay, and r equals to 3. હવે આ રીતે તમે કન્ટિન્યુઅસલી વેલ્યુ પુટ કરતા જશો તો અપ ટુ લાસ્ટ હું સેકન્ડ લાસ્ટ ટર્મ લખું છું પહેલા સેકન્ડ લાસ્ટ ટર્મ ધેટ મીન્સ r equals to n minus 1. Second last term that means r is equals to n minus 1. So put r is equals to n minus 1 here. We are getting nc n minus 1, nc n minus 1, a raised to n minus 1. તમે બ્રેકેટ ઓપન કરી સિમ્પ્લિફાઈ કરશો એટલે તમને a raised to 1 obtain થશે. a raised to 1 into b raised to n minus 1 into b raised to n minus 1, and the last term r is equals to n. By putting r is equals to n, we are getting plus ncn a raised to n minus n, that means 0, b raised to n. Okay, so this is the binomial expansion. જોઈ લો આ છે. This is the binomial expansion of a plus b raised to n, which can be also written as sigma r equals to 0 to n ncr a raised to n minus r b raised to r. તમારી બુકમાં I think વેરિયેબલ r ની જગ્યાએ k લીધો છે તો k ના ફોર્મમાં આ રીતે લખાય sigma k equals to 0 to n ncr ની જગ્યાએ k a raised to n minus k or b raised to k. Okay, here sigma r is equals to 0 ની જગ્યાએ k equals to 0 to n nc k a raised to n minus k b raised to k here. Okay, so this can be obtained by use of this. બાકીના બધા ઓબ્ઝર્વેશન્સ ઓલરેડી આપણે ડિસ્કસ કરેલા છે. હવે જો એમાંથી એક ઓબ્ઝર્વેશન છે ટોટલ નંબર ઓફ ટર્મ્સ in the expansion of total number of terms in the expansion of a plus b raised to n are n plus 1 इंडेक्स करता एक टर्म વધારે આવશે. સપોઝ a plus b raised to 5 નું એક્સપાન્શન કરીએ છે, then we will get total number of terms which is equals to 6 here. 1 2 3 4 5 and 6 terms are there. Total 6 terms આવશે. Same way, if we want to expand a plus b raised to n, then we will get the number of terms equals to n plus 1. एक टर्म વધારે મળશે, n plus 1 term obtain થશે. Clear? Now we are going to discuss some special cases. Some special cases. First case, if a equals to 1 and b, suppose a equals to x लेंगे पहला, a equals to x and b equals to -1. If we are taking a equals to x and b equals to -y, then we will get x minus y raised to n will be equals to, so x minus y તમે obtain કરવા જશો એટલે તમને મળશે first nc0. ચલો first term power x ની power n, second term minus y will be there plus આપણે સિમ્બોલ જો કમ્પેર કરો તો a equals to x, b equals to minus y and n is equals to n here. Therefore we are getting nc0 a raised to means x raised to n and b raised to b means minus y raised to 0 here plus nc1 x raised to n minus 1 minus y raised to 1 plus nc2 x raised to n minus 2 minus y raised to 2 plus nc3 x raised to n minus 3 minus y raised to 3 here plus up to I am going to be last term. So second last term write down here. nc n minus 1 x raised to 1 and minus y raised to n minus 1 plus ncn x raised to 0 minus y raised to n here minus y raised to n. Therefore, we can write it like this: nc0 x raised to n minus y raised to 0 and y raised to 0 લખી દો તો ચાલે. Okay, it can be calculated y raised to 0 also plus nc1 x raised to n minus 1 and minus y raised to 1 तो minus y तो माइनस सिंबल में अगर आप लिख दो y raised to 1 as it is रहेगा plus nc2 x raised to n minus 2 minus y raised to 2 that means y raised to 2 here and આપણે y raised to 2 લખીશું. Next nc3 plus nc3 x raised to n minus 3 minus y raised to 3 means y raised to 3 અને આગળ જે માઈનસ સિમ્બોલ છે એને આગળ આપી દો minus y raised to 3 is going to be plus ncn x raised to 0 minus y raised to n. Here last term the symbol the sign positive or negative depends on the value of n. If n is even then it is positive, if n is odd then it is negative. એટલે મેં અહીંયા minus y raised to n ના ફોર્મમાં જ રાખ્યું છે. n even છે કે odd એ આપણને અત્યારે ખબર નથી. બટ એટલું તો ક્લિયર થઈ ગયું. જો ફર્સ્ટ ટર્મ પોઝિટિવ સેકન્ડ નેગેટિવ એટલે કે જ્યાં આ નંબર ઓડ આવશે ત્યાં નેગેટિવ સાઇન આવશે. જો ઇવન આવ્યો તો પોઝિટિવ, ઓડ આવ્યો ક્લિયર તો નેગેટિવ સાઇન. ઇવન આવશે નેક્સ્ટ 4 આવશે તો પોઝિટિવ આવશે એના પછી 5 આવશે ત્યાં નેગેટિવ. તો પ્લસ માઈનસ ના સિમ્બોલમાં આગળ આ કન્ટિન્યુઅસલી ઓબ્ઝર્વેશન્સ જશે. તો આ એક સ્પેશિયલ કેસ છે. આમ જોવા જઈએ તો કશો કેસ નહીં ગણવાનો, આ બહુ સિમ્પલ છે. તમે ખાલી વેલ્યુ પુટ કરીને સિમ્પ્લિફાય કરવાનું છે તો ઈઝી છે, કશું બહુ ચિંતા કરવાની જરૂર નથી. સેકન્ડ બીજો એક કેસ છે બરાબર છે, એ કેસ બી આપણે ઓબ્ઝર્વ કરી લઈએ. તો સેકન્ડ કેસ if a equals to 1 and b equals to x, so a equals to 1 b equals to x, then the 1 plus x raised to n. A equals to 1 b equals to x raised to n will be calculated as which is equals to, so start with nc0. So nc0 1 એટલે a raised to n, a raised to means 1 raised to n, 1 raised to n and x raised to 0 plus nc1 1 raised to n minus 1 decrease the power of 1 and from n to n minus 1 x raised to 1 plus nc2 1 raised to n minus 2 x raised to 2 plus up to last term we are getting ncn 1 raised to 0 and x raised to n. The power of 1 will be going to be decreasing from n to 0 and power of x will be increasing from 0 to n in successive terms. Clear? Now simplify this thing. We are getting 1 raised to any power which is equals to 1. We can write directly here nc0 and any value भी તમારે લખવી હોય તો 1 લખી દો તો ચાલશે. 1 into 1 that means 1 plus nc1 1 plus nc1 which is also equals to n. nc1 is n, this is 1, it is equals to x plus nc2 calculate ના થાય આપણે ડાયરેક્ટલી લખીએ nc2 x raised to 2 plus nc3 next term will be x raised to 3 plus up to last term ncn which is also equals to 1 x raised to n. તો તમે 1 plus x raised to n ને ડાયરેક્ટ લખી શકો 1 plus 1 means nc0 plus nc1x plus nc2x square plus nc3x cube plus ncn of x raised to n. રીઝન એ છે કે આ 1 આવી ગયો એટલે એની પાવર ગમે હોય એની મલ્ટીપ્લિકેશન 1 થઈ જશે એટલે એ મલ્ટીપ્લિકેશન માં થી કાઢી નાખશો તો બી ચાલશે આ એવું કે છે. સપોઝ એ 1 minus x હોય તો 1 minus nx plus nc2x square minus nc3x cube plus nc4x raised to 4 up to એ પ્લસ કે માઈનસ ડિપેન્ડ્સ કરે છે n even છે કે ઓડ એના ઉપર. જો even હોય તો પ્લસ આવશે, ઓડ હોય તો માઈનસ આવશે. બરાબર. તો આ કેસીસ ભાઈ બહુ એટલા બધા ઇમ્પોર્ટન્ટ નથી અને બહુ એટલું બધું ઇમ્પોર્ટન્સ ના આપશો, બહુ ઈઝી છે. આ તમે વેલ્યુ પુટ કરી સિમ્પ્લિફાય કરો આન્સર આવી જશે. બરાબર છે. હા, હવે જે ડિસ્કસ કરવા જઈ રહ્યો છું એ ઇમ્પોર્ટન્ટ રિઝલ્ટ છે. if a equals to 1 and b equals to 1, ચલો a equals to 1 અને b ની વેલ્યુ બી 1 લઈ લો. ચલો b ની વેલ્યુ બી 1 લઈ લો એટલે અહીંયા શું મળી જશે તમને? અહીંયા જે રિઝલ્ટ મળે છે એ રિઝલ્ટમાં x ની જગ્યાએ પાછું શું આવશે? 1. તો 1 1 1. therefore we are getting only summation of 1 plus x raised to n. x ની જગ્યાએ 1 પુટ કરીએ છે, therefore we are getting 2 raised to n which is equals to 1 plus 1 means 2 raised to n which is equals to nc0 1 raised to n 1 raised to 0 1. આ લઈ લખો તો ચાલશે, plus nc1 1 raised to n minus 1 1 raised to 1 that means it is also equals to 1 plus nc2 plus nc3 plus up to ncn. This is most important result for calculating the JEE MCQ. That means we can directly write down 2 raised to n if nc0 plus nc1 plus nc2 plus nc3 up to ncn is there. જો આ આવતું હોય તો બહુ ઇમ્પોર્ટન્ટ લોજિક છે, બહુ ઇમ્પોર્ટન્ટ રિઝલ્ટ છે. nc0 plus nc1 plus nc2 plus nc3 up to ncn which is equals to 2 raised to n. જે n પાવર હોય એ મૂકી દો. સપોઝ 5c0 plus 5c1 plus 5c2 plus 5c3 plus 5c4 plus 5c5 is there, then the answer is 2 raised to 5 directly. તો એ ડાયરેક્ટલી આન્સર માટે આ જનરલી માટે ઇમ્પોર્ટન્ટ લોજિક છે, બહુ ક્લિયર કટ છે, બહુ ઈઝી છે. અહીંયા 1 પ્લસ x ની જગ્યાએ બી 1 પુટ કરો તો x ની બી પાવર 1 થઈ જવાની એટલે મલ્ટીપ્લિકેશન એનું જે આવતું હશે એ થશે. એટલે મેં કોએફિશિયન્ટ nc0 ના ફોર્મમાં રાખ્યા છે તો એ રીતે લખશો તો એ વાંધો નથી. સપોઝ તમે એવું વિચારો કે સર મારે અહીંયા કોએફિશિયન્ટ nc ના ફોર્મમાં લખવા છે તો ncr ના ફોર્મમાં લખો, nc0 nc1 તો બી ચાલશે. ક્લિયર? તો આજના વિડિયોમાં આટલું રાખીએ. ચલો, આજના વિડિયોમાં તમે ઘણું બધું લોજિક્સ નવું શીખ્યા, ફોર્મ્યુલા શીખ્યા. ધીસ ઇઝ અ બાયનોમિયલ થિયરમ. આના રિલેટેડ ઓબ્ઝર્વેશન્સ તમે રાઇટ ડાઉન કરશો. બરાબર. તો આજના વિડિયો લાઈક કરો, કમેન્ટ કરો. આપણી આ ચેનલને હજુ સુધી સબસ્ક્રાઇબ ના કર્યો તો ખાસ સબસ્ક્રાઇબ કરો. થેન્ક યુ વેરી મચ.